Hello and welcome back to Math 131. We're picking up where the last video left off, which is here on our home page at week 0. Towards the bottom of the page, we started saying that we're going to do all of the lessons, notes, and assignments in Google Colab notebooks. So this video serves as our introduction to Colab notebooks. Let's click this link and follow the new tab that's opened up. You'll have access to this page, a Google Colab notebook for week 0, if you are already signed in with your Chico State student account. If you're not, please do so now so you can view the page. Colab notebooks allow us to create reproducible documents that weave together text and code. And so all of our Python programming will happen within a Colab notebook like this. What you can see here is a bunch of different text cells. I just double-clicked on one of them so you can see the text used to create this header. Any cell like this can be double-clicked on so you can go edit the contents of it. And this is how we'll start putting text into our notebooks. We'll get to code in just a second, but let's just pick apart some of the different pieces of the notebook that we can see immediately. Some text shows up in paragraph form, some text shows up as headers, some text shows up as subheaders. In fact, to help us navigate the document, we can use those headers, like week 0 here, and the subheaders. The headers are created with a hashtag before whatever words you want, and that will make the words a little bit bigger and a little bit more bold. Subheaders show up as double hashtags. Effectively, the more hashtags you use, the more layers down in the header sections you'll get. So if you were to use 3 hashtags, we'd get a sub-header, and theoretically table of contents would update as indented here, but it might take a second for it to do so. So you can use this table of contents to help you navigate the structure of this document if you want. So we just went through table of contents here. We found the symbol that looked like a bullet point in the left of this Colab notebook. And you can use that to help you navigate wherever you want. Because only these 2 paragraphs are within the subheader of table of contents, we can help ourselves further navigate this document by just closing the pieces of the notebook we've already covered. In fact, this next section named Markdown is describing the syntax of the text cells that allow us to create things like the table of contents that Google Colab knows how to format for you to help you navigate. Further, if you just double-click on this text cell, you can see there's some extra code here that creates for us this link in the output. So Markdown is a way to write extra text into your document to ensure you get differently formatted text as you go. You can create headers, subheaders, URLs, you can make text bold, or you can make text italicized. There's very limited things you can do, but it turns out with just a few options, you can get very nicely formatted, simple documents. Here is a guide to further Markdown options you can use within a Google Colab notebook. So I'm just going to, from in here where I've started editing this document, I'm just going to hit Shift and Return or Enter. Hold Shift and hit Return or Enter, and that will get you out of the edit mode of a text cell. Okay, so there you can see this text is not bold, it is striked out. Let's go change that right now. Bold uses 2 asterisks. Holding Shift, hitting Return, and we can see this text is bold. Okay, Markdown. This Google Colab notebook I own. You don't own this one. It lives in my Google Drive account, not yours. All of the assignments and notes I've created for this course are files that I own. But in order for you to do an assignment, you'll have to edit a Colab notebook that you own. The best way to do that is to copy the Google Colab notebook that you open for an assignment and move it into your Google Drive account. Let's try. If you go up to File and click Save a Copy in Drive, this will copy any notebook into your Google Drive account. In fact, as we go through this lesson, I'm going to tell you to navigate to the menu bar a number of times and then tell you what to click on. It's such a common series of steps to follow that programmers like to organize them in text like this. The file there says go up to the menu bar, File, and then is written with a greater than symbol, save a copy in Drive. So in order for you to complete an assignment, you'll go open up an assignment as a Colab notebook like this, click File, and then click Save a Copy in Drive. Great. We've already seen text cells. There's also code cells. So all of the cells we've seen above here that maybe we double-clicked on and edited are text cells. But in fact, you can also have code cells. And this is where Google Colab allows us to enter in Python code. So here's a code cell with some Python code. You could similarly double-click on that. And then if you want to run that Python code, you'll hold Command or Control if you're on a Windows machine and hit Return or Enter. You'll get a little spinning wheel right here telling you that the Colab notebook is thinking, and when it's done thinking, it'll output whatever the commands in Python were meant to do. So here we just ran our first Python code, and all it did was some addition for us. In fact, you can create from any cell you want another cell above or below it by moving your cursor from the cell you're in to the space in between two cells, and you can add a code cell or add a text cell. So we'll just add a code cell and then go about typing in any Python code you want and then running that code. I'm going to hold Command and hit Return, but I'll also show you that you can just click this play button right here to run a cell. It will send the code off to the server that Google owns to run this notebook and put the output into the document for us. And this is what we mean generally when we say we're going to weave together text cells with code cells and then maybe more text and maybe more code cells. This is how we're going to create a reproducible document. Anytime you want to delete a cell, just put your cursor in the cell you're going to try to delete and go click this little garbage can. Great. Mistakes happen. Sometimes you want to be able to undo something you've done, and you can hope for the best with the undo features built into Colab notebooks by going Edit and Undo. In this case, my last operation was to delete a cell, so you could undo the deleted cell. Undo as a feature only works so in the world of Google Colab notebooks, but we'll hope for the best if it ever happens to you. Otherwise, you might just have to recreate some code you might have deleted or change up some code you might have edited. Okay. That's all we really need for text and code cells for now. We will get plenty more of that later. This next subsection here in the Colab notebook is letting you know a little bit more about how Colab notebooks work. Colab notebooks are actually run on a computer that you don't see and don't directly touch, and certainly don't own. There's some server that Google owns. Google allows us to interact with these machines through code cells. That's great. But there are some downsides to this. Google Colab notebooks don't really save anything except what you type into cells. So if your code depends on a dataset, as your code soon will, your dataset might be removed from the computer that is running the Colab notebook. That's a little bit annoying, but we can certainly deal with it. First, let me just show you what this might mean. Imagine you're going through this notebook and you've added a cell and you're going to deal with some data set. This is certainly not Python code, which is what all these underlines have to do. But that data set, theoretically, will come from somewhere. And probably it'll be a file that you upload to the computers that are running the Colab notebook. So here on the left, there's this folder files icon, and you could drag and drop some data set into this space here such that you upload a data set to the machine that is running the Google Colab notebook. And then with that, you could go deal with some data set. That's great. But right now we're learning about the pitfalls of using a computer that you don't own. So let me see if I can make this a little bit more tangible. Here is some frustratingly more not Python code, but it is code that allows you to interact with the machine that is running the Google Colab notebook. Anytime you see a leading exclamation point, which are sometimes called bangs, this is code that's telling the computer the notebook is running on to call the program named wget, which will quietly download the following URL. Let's try downloading this births.csv file by running this cell. Now you can see after running that cell we got no output, but in fact we now have births.csv in our folder on this machine that Google owns. That's great. We could then begin to use that data set in our notebook so long as this tab is open and active. Google doesn't tell you what active means. And further, Google reserves the right to delete this CSV file if at any time you close this notebook. It won't tell you when or why it thinks it needs to delete births.csv. It just reserves the right to do so. So here is the first of pitfalls dealing with Colab notebooks. The state you might create in a notebook, like a data set you've uploaded to the computer that Google owns that runs your notebook, that state is ephemeral at best. Google reserves the right to delete that state at any time you're not engaging with the notebook, and it won't even tell you when it's happened. There are other pieces of state you might create when using a Google Colab notebook. For instance, we will make heavy use of a number of Python packages that are not already installed for Google Colab. We could call to the underlying computer running this notebook to the program pip and ask pip to install quietly the Python package named plot9. Let's do that. It takes just a minute for that to happen, and no output follows from that. But in fact, we have changed the state of the underlying computer that runs this Colab notebook. We are going to use many Python packages throughout this course. We might have to install some of them. It's best, for reasons I'm not going to get into, that if you ever run a command that looks like this, where pip is installing some packages for you, it's best to then click Runtime, Restart Session, and if there's a prompt that says, "Are you sure?" you are sure. After that, everything should work as fine, but if you forget this step, immediately following a pip install, you might get some error messages that are honestly quite challenging to debug. So we'll just leave this as a little reminder that sometimes we need to install or create some state on the computer that a Google Colab notebook is running on, and sometimes we need to restart the session in order to best use those newly installed packages. Okay. Next subtopic. When you're dealing with Google Colab notebooks, they will easily get lost in your Google Drive folder. So I'm encouraging you to organize all the files associated with Math 131 into a folder or directory named Math 131 on your Google Drive account. Here's some instructions I'll leave for you for logging into your Google Drive account and making a new folder. And here is the general strategy I recommend to you for naming your Google Colab files. For all your notes, you should name them simply week dash the number of the week dash notes. That way, all of your notes are organized together. 01, 02, 03, 04, 05 notes. Similarly for your assignments. Week 01 assignments, week 02 assignments, week 05 assignments. This way, all of your notes will be next to each other and all of your assignments will be next to each other. If you need some help on moving files within your Google Drive account, here's a few set of instructions I'll leave to do on your own. This next subsection of a Google Colab notebook isn't really dealing with Google Colab in any particular sense, other than I'm strongly encouraging you, for your own benefit, turn off the AI intelligence features of the notebook. Effectively, if you don't understand Python and programming yet, getting AI to fill in the blanks for you is not going to help you understand or memorize anything about Python programming. So, here are my recommendations. Step 1. Metaphorically, bash your head against the desk for 10 minutes trying to understand something new in a Google Colab notebook. If, after an honest 10 minutes, this productive struggle doesn't work, consult me, Edward, during office hours. My office hours are listed in the syllabus. There's a link. If I'm busy and you've waited for me for 10 more minutes while really thinking about your coding problem, you could consider then, and only then, consulting some large language model with your programming question. But I encourage you, after immediately copying and pasting the solution and ensuring it works through a runtime, restart session, and run all, to make sure there's no errors involved, you should spend at least 5 minutes reading the code the large language model produced so that you can understand and reproduce the code from memory. Now, if you're willing to follow my advice about the AI, I encourage you to go to the settings, AI assistance, uncheck show AI-powered inline completions, and do check hide generative AI features. I believe that will help you come out of this course with a better understanding of Python. This little section here about LaTeX, we won't type much math in this course at all, but it's good to know that Colab notebooks allow you to type the special mathematical syntax called LaTeX that gives you nice, well-formatted math output like this. Down here in the last section, references, I give you links to a markdown guide that we mentioned above. I give you a link to another introduction to Colab notebooks. This one's a little bit more in-depth, but we'll cover everything that this notebook covers later on in this course anyway. And here's some other pieces on LaTeX, because I'm in a math department and I like to promote LaTeX.